Welcome to video 2 of our Trident series. In this video, we'll be learning to force a live program. Now, we've already done introduction to Trident, seen what it's about, see what it does and the usefulness in the ecosystem. So it's time we force a live program and see how Trident actually works under the hood and see how it actually works with code, not just theory. So we have an integer overflow program here, and first step to initialize Trident, if you check your docs, we have our docs here. If you check your docs, you can see first of all installation. But we have done that already, we installed already. Then we look for commands. Now Trident init initializes Trident workspace and generates new force template. So we come here and we write the command Trident init. I've already installed my Trident, so I just initialize it. Now we see a folder is created here. You can see this is the harness, test harness. You can see here. So a force account RS created, storage for all account addresses. This struct mirrors all the accounts in your program. This integer overflow program, let me show you. To rs. Let's look for an account struct. So user account, owner, vaults. You'll see most of these here. See them here. Mirrors all the accounts in your account structs. Puts them here. For it, then we have test force. This is where we write in our first test. So this is templates showing us flow, init, flow, and you know what flows are? Flows are used to perform certain logic in your program. Like your withdraw instruction can be a flow, deposit instruction can be a flow, exchange instruction can be a flow, end is just for cleanup, start is for initialization. So your accounts, your PDAs, and the rest of them will be initialized in this init part here, this start function. That's where you initialize them. Then simple, this initializes a Trident client, picks the account addresses, and then we can work with it from there. Then types of RS is just a generated type file from all your types in your program. So just mirrors them and create types that uses during fuzzing, and we'll see how to apply them here. So first, like I said, we are to initialize. Okay, writing first test have pattern. Like first test has patterns in writing them. The way I follow it is first of all, I start with the init macro, the code that stays there. So now we have a withdraw. Okay, an integer overflow program. Yeah, let me look at what the program is about. Here is a deposit withdraw. Is an intentionally created vulnerable program. Like I created it to be vulnerable and I created a secure version. It's from a past series on security. So I just want to use it for this demo. So there's a vulnerable version and there's a secure version. So they're pretty much the same thing, but just with a bit of changes. Then, like I said, the first thing is if you follow through this program, first of all, a vault is initialized, and then user account is created, deposit is made, then withdrawal. I think that's pretty much everything. Starting out this program, first of all, we need to initialize accounts. What accounts do we need? We need like the authority accounts. See how I do it. This initialize vault now. Let's go to the. So you see, we need the authority account, the vault, and the system program. The program is already automatically generated, so we just come here, automatically added rather. We come here. So my flow is get slash init accounts, construct instruction data, um construct transaction, execute transaction. Yeah, this is pretty much my flow. Let me reduce this. We'll come back. We can test on the terminal here. Yeah, so hold on, let me swap this. Yeah, so executing transaction. That's pretty much then you can invariant checks. Yeah, assert, you can assert and the rest of them. So let's flow this and see how we get to the end. Now get slash init accounts. Like I said, I follow the account struct. We've seen the authority account, the vault, and then the system program. So we have this already passed in here. This is an implementation, and then it's already passed in itself. So we have let authority equal to, you can even see the autocomplete, but yeah, self the false accounts. I think I need to disable it so we follow through proper. I don't know. But sell the false accounts. False accounts here is the account address store, which I showed you here. Please. So we'll pick the authority. They are, first of all, empty placeholders are created. That's why we have this. All these are empty for now. Until you write in, then they have values. So first set the false accounts, the authority dot insert. We use the insert um insert function. You can read about it here. Insert a new address into the storage. Generates a new address and stores it. If PDA seeds are provided, attempt to derive a PDA. So simple, use the insert, and then takes in immutable, and then we have table self and trident, and if there's seeds, so we just have self the trident, and then there are no seeds for this, so we just put on. I think I need to disable this auto stuff. It's so arguments found 3. Hold on. Sorry, I made a mistake. It's the autocorrect is messing with my brain. Yeah, so this is what we need to have authority. Then next is vote. So follow the same pattern, initialize vote to be fast. But now votes, as we said, I think votes is a PDA. So something will change here. Here. So do some. I think we have a PDA seeds struct. Then seeds are come back here. Remember, I said this is a guided fuzz. So you state it like you're writing tests. So you calm down and you state it out, your instructions, your seeds and all. So seeds, this. So we have, I think the pretty much same way we write seeds in Anchor. So it's just like that. We have, I think, something like this. Yeah. No, no, no. Yeah, something like this. Hold on. Sorry, forgot this. How many seeds we have? We're just using the vote. Yeah. Then program ID, we can pull it in from here. Program ID, we pull it in from, based on the program you're using. We have a secure and have a vulnerable version here. So I think we need to import it. For now, let's work with the vulnerable version. Let me see if I can do vulnerable. Okay. So I think we're good this way. I think this works. Yeah, so we've defined the seeds, we've defined the program ID, and then we can continue to the third one. The third one is sorry, I keep clicking this system program. That one is already automatically inserted by the current SVM and all, so don't necessarily state it. Then I think all we need again is we don't need anything yet again from this account struct because we've done this too. Then we proceed to writing the fuzz. Yeah, so now we've initialized the account, then we construct instruction data. Now the beauty of Trident is the fact that it can give you random inputs. So instruction data here is not fixed. It's kind of random. We swap accounts, swap flow, swap instruction data to see if any vulnerability can be picked or can be matched. So here we use something like this. Now this generates initialize void that takes in, let's go back, let's go to the function. It takes in an amount, U64. So for us to use this proper, like for us to force proper, I will not put in just 1 million or 1 soul or 2 soul or anything. I'll put in a range of numbers, tell it to pick from this range of numbers and try with them. So I can say let input equal to self.trident dot, we have I think random from range. Yeah, this function random from range. Then we have, I think it can do something like this, 0 to, let's say U32 max. We can do this. So we can do something like this, and we have this. So it would force with numbers from this range 0 to U32 max instead of just giving one number, which your unit test normally would do. But this is the reason why we need fuzzing, so we can throw in random inputs and see how the program reacts to them. So this is inputs and there. Then I really need to cancel this auto suggest. I don't know how to do that, but maybe I'll pause the video at this point and cancel it and come back. Just leave it out. construct transaction. Now we've construction instruction data. Now it's time to construct the transaction, or rather, wait, yes, construct transaction. Yeah, not construct instruction. I mean, you construct an instruction, then you wrap it into a transaction, and all, then continue. So first we have those types I told you that were generated from types arrays. We have them here, here. So we can say let instruction go to initialize vote instruction. Then normal way of constructing instructions in Solana, you attach data, you attach accounts, and then that's all. Yeah, data, accounts, and that's all. So we have data first. Our data here is this input. Put it in. But it doesn't work that way. Remember, I said we have types. So we have initialize vote instruction data. We have this type. And then we put in inputs. Yeah. So now we've initialized our data. Then, but we have an issue here. Expected U64 532. Yeah, that's simple. We can just cross it. I think this does it. Convert this into the type. That should fix it. Yeah, it fixes that. Then we can proceed to counts. We have here initialize vote accounts. Let's keep this. Um, let's wrap it. Still the same. We can do new. Have authority and vote. It already completes that first time. Then we just call the instruction method. And this ends our flow. Then moving over to executing instructions, or executing transactions rather, we can just say let results equal to self.trident dot I think process transaction. The instruction, if there are multiple instructions, you can change them, I guess. We'll come to that in one of the videos. Have ix. Then log as I can say, what does this take in? Takes in a hold on. Takes in an option. So I can say initialize vote. Yeah, I'll definitely cancel this autocorrect. Yeah. No, it's just too messy. So okay, need to borrow. Is it this? Sorry. Am I making a mistake? Yeah. So this is pretty much the end of this. Yeah. So we can just, I think, if we can try to execute the first test first before we come back. Let's try executing the first test. So from the docs, we first with Trident false. Yeah. So first run, first target. So to do that, while we're in the initial overflow directory, we move into Trident test. Then yeah, just run Trident false run. I think this is, we didn't name it, so you have for 0. We just run for 0. See what happens. Let's just see our first run. Oh, it has to compile and all. So I guess we'll have to wait for that. Then yeah, so I think that's done. We can see our results here. Yeah, so we just see initialize vote run 994 times. Instruction success 0 failed 994. Yeah, so going back to that, explaining why this table is like this and why we have this value. So back to our instruction, it's saying instruction field. None of the instruction passed. Meanwhile, we are just initializing. Why would none of our initialization processes pass? Like, I'm not doing any serious stuff yet. So I think the reason for that is maybe let me see. I think the reason for that is no tokens, like no gas fee. Put it that way. So we need gas fee on these accounts for signing. Imagine a signer here not having any gas. So I think we need gas there. And I think we can log here. So there's a log command in Trident to see. Let's see if that log command is here. So you can, while you're forcing a log, so you can see the error, where the error is coming from, why it's generating that particular error. So where is it? Let's see. So this is where we did all those stuff from. So this is how to construct instructions, how to fuzz, setting up data like I told you using randoms, and then setting up accounts, PDAs. All these are you'd find them in the Trident docs. Yeah. If there's need for remaining accounts too, you can do that. What I'm looking for is the log. I think I remember the command to be let's see. Trident false run false 0 trident underscore log equal to 1. I don't know if it's something like this. It's not. It's not. So it's something like this. So it can log. I'll look for it. And once I see that I'll add to your there's a log command. It's a way to change. It's a way to request for logs. Why fuzzing? Yeah. So yeah. See here. See here. So I think it comes front at the comes first. So trident underscore log go to 1. Love trident fold 1 fold 0. Let's see. So constraint seeds. You see the error from the programs. Get them from the see initialize votes. So you can see all the errors and see where they're coming from. Error seed constraint was violated. We have the other one. I think for the most part is seed constraints. Yeah, so let's check it out. Why? Let's see what we did wrong. So we'll come back to our PDA seeds. Let's get back to personally. I also think we need to airdrop tokens too. But let's check out the seeds. I think here. The seeds out here. What did we do wrong? Let's see how the right seeds here. Let's confirm that we're not hallucinating. Yeah, so some PDA seeds. So we have this passing the seeds, then the program ID. Yeah, so honestly, I think that's correct. So why are we having errors? Hold on. Why are we facing errors with that? I think that's correct. Oh, hold on. First of all, let's airdrop tokens first before I forget to do that. Let's have the airdrop. Can just have authority. I think it takes in. I want to drop on so I think this is enough. Yeah. So executing function. So just have let's do that for vote too. No, sorry. I'm not supposed to change this. It's just call it and then have it do this job. Sadly. Yeah, so we have let's try it again first. Let me confirm the airdrop stuff before we come back to checking why we have seed constraint validation. Seed constraint was validated. So you after a long search, hold on. I think this is the issue. So after a long search, I think this is the issue. I think I'm supposed to use secure here. Sorry. We're dealing with secure program and I put in the vulnerable program ID, so that was causing the mismatch. Let's see if it fixes that. Yeah, insufficient lamp ports now. Yeah, good. So we have another error. So some instructions are failing, some are passing. And I don't understand that because it's fuzzing. Fuzzing gives you random inputs. So some inputs are meant to pass, some are supposed to fail. So your program is not supposed to allow everything to pass through. So if you write a program and you fuzz it and everything is passing, it means that there's the issues with your program. Add invariants to check and confirm the state of your program. So the vault is initialized, but we need insufficient having sufficient lamp port issues. I guess that's from the authority part. Let's add more. So see if that works. Yeah, that works. That works. So we can see initialize passing here. And yeah. So I believe okay, we'll get to that. Hold on. So now we have this. The next thing to initialize is user accounts, judging from this. Yeah. And on vault initialization, the reason why this one is excluded and all can pass is because okay, let's finish this first. So we head over to this. We have user account system program. Just head over here. Similar. Just let's user. Yeah. So just have this quickly. The user account is similar. Have this. Well, I don't think user is it PDA. Sorry, get PDA. So we just some what is here we have this. So yeah, it's doing. So drop this account to safety net. Then we instruction data for initializing user accounts. Check out the instruction. Let's see that. It doesn't take in anything, so it's pretty simple to write. We just have let's create user ix is equal create user instruction data here is just empty. Then have the accounts. We have initialize vault account. You know, we have user account. I really need to disable this. Our next video, which it won't be there. Yeah, we just do it for this. Very apologies for breaking transmission. This is really disturbing the flow. Yeah, so this takes in creates just takes in an empty. Hold on. What's the issue with this? Separate this with TI auto in hold import it to I think should work now. It's imported. So we just add this to just call it to this. Yeah, so let's check it out. So similar stuff here. User account created. This works. Yeah. As I was saying, initially I talked about some instruction filling and passing, but in this state we're just initializing a vault. So we only have from 0 to like U32 max. And from the way our instruction is designed, just create a vault regardless of the amount given. Like just create a vault to the given amount. So it will always work in the right sense via fuzzing, except you're changing authority and vaults. That's where you start having issues with this. But for now, our fuzzing was just on random range, like the inputs So that works. So we're done with this basically. We don't have invariant checks for now. So we're not doing it. We're just initializing. Just keep this.